Okay, now we're looking at remainder and factor theorems. So, dividing polynomials, that's what we're doing today, dividing polynomials and factorising them. So, dividing polynomials helps us to factorise them, which in turn makes sketching their graphs easier. So, there are two theorems that will also help us to work with polynomials, and they are the remainder theorem. Now, you know when you, let's say you just divide two numbers. When you divide a number into another number, you'll either get no remainders or you'll get a remainder. Same with polynomials. When you divide a factor, or when you divide one of the factors, like or x minus a into a polynomial, you'll either get no remainders or you'll get a remainder. Now, there is something called the remainder theorem. If a polynomial in x is divided by x minus a, the remainder is, if you substitute a into the polynomial, that is the remainder you'll get. Now, I'm going to show this by example, all right? Just going to leave this here. I'm going to come back to that. We're just going to learn to do a division first. So I'll explain this in a minute. Let's just do this. We're going to learn how to divide polynomials. So, I'm going to divide this polynomial, x cubed plus 3x minus 6 by x minus 2, and we use long division to do it. All right, so here we go. X minus 2 into x cubed plus 3x. Wait. X cubed, ladies, what do you notice about this? X cubed plus, there's no x squared term, but I have to put it in, plus 0x squared, otherwise you're going to ruin your division, plus 3x minus 6. I cannot miss a power when I'm dividing. So, I want to divide x cubed plus 3x minus 6 by x minus 2, so you know how you put the x minus 2 at the front, but I don't have an x squared term, but I have to show it. I have to show the x squared term as a 0x squared plus 3x minus 6. Now, all you do, you say, how many times does x go into x cubed? Well, yeah, sorry. If I do x into x cubed, I'm doing x, sorry, it's not 3. X times what gives you x cubed? Isn't it x squared? That's what I'm trying to say. Sorry, x cubed divided by x is x squared, or x times what gives you x cubed? It's x squared. Got it? So what I have to do now, basically x cubed divided by x is x squared. So I go x times x squared is x cubed, negative 2 times x is minus 2x squared. So what I now do is multiply this x minus 2 by that x squared. Just for the first two terms. Well, you'll only get two terms. So x into x cubed, like x cubed divided by x is x squared. Now I multiply that x squared by the x and multiply the x squared by the negative 2. And put it underneath those two terms. Do you see why I had a 0x squared term? Now I subtract. Now you only do two terms because it's x squared times that and x squared times that. The idea is that I eliminate now the x cubed. Let's subtract. X cubed minus x cubed is 0. What's 0 minus negative 2? Positive 2. So 2x squared. Now to do the next bit, I have to bring the next term down, plus 3x. Okay, so I bring the next thing down. So I had a 2x squared. I bring the next thing down. I say x into, so I'm going 2x squared divided by x, or x into 2x squared. Isn't it plus 2x? Because x times 2x gives me 2x squared. Yes? So now I multiply this 2x by each of those, and I put them underneath. So 2x times x is 2x squared. 2x times negative 2 is minus 4x, and I subtract. Should always lose the first one, otherwise you're doing something wrong. 2x squared minus 2x squared is 0. 3 take away negative 4 is 7x, and bring the minus 6 down. So, 7x divided by x, or x into 7x, what do you get? Plus 7? 7 times x is 7x. 7 times negative 2 is negative 14. 7x minus 7x is 0. Be careful now. Negative 6 take away negative 14 is positive 8. That's your remainder. Your remainder is 8. Now, therefore, I can say Why are we doing this? To find the other factors. Therefore, I can say, now just watch what I'm going to do. You know, if I've got, say, 4 into, say, 35, what does that equal? I'll show you long division now. I'll do this with long division. 4 what? 4, 8, so 32. You go 8, 32. That's how you do a sort of a long division. You say 4 goes into 35, 8 times 4 is 32, and you subtract. Doesn't this mean that 35 equals 4 times 8 plus 3? Yes? So that, what you're dividing into, 35 equals 4 times 8 plus the remainder. Got it? You can do the same here. This x cubed, I'm not going to write plus 0x squared, I'm going to go plus 3x minus 6 equals that times that, the divisor times, this is the divisor, what you're dividing by, this is the quotient. You know when you divide two numbers and you get an answer, that's called the quotient. Okay, so it's your divisor times your quotient plus the remainder. Now, if the remainder is 0, it means it divides into it evenly. See, I have a remainder here, but if I did 4 into 36, let's say I did 36, 4 into that is just 4 times 9 with no remainder. So sometimes you get remainders, sometimes you don't. All right? Now, so my remainder's 8. What they say is, I can work out that remainder by doing that long division, or I can work out the remainder by using the remainder theorem. See how my remainder is 8? So the remainder is 8. So here I'm going to write, see how I've got this? You know always your original polynomial is your polynomial in x, all right? This, your x minus a, that's your, we call that, so sorry, just continuing this from last lesson. We've just had a break in the video. So therefore we can say that x cubed plus 3x minus 6 equals, so this equals x minus 2 times x squared plus 2x plus 7 plus 8. So, in that format, this is the polynomial, your dividend. This is our divisor, so px equals ax times, this is our quotient, result of our division, plus our remainder. Okay, so remember we did that last lesson. But remember that we can also write this another way. Okay, we could also write this as follows, that x cubed plus 3x minus 6 divided by x minus 2, because that's what we're doing. We're dividing it by x minus 2. Do you remember how we write this now? So if you divide that by x minus 2, what do you get? The quotient, which is x squared plus 2x plus 7, plus, we do our remainder. What's that? Plus 8 over what? Over x minus 2. Okay? So that is really just the first expression dividing each term by x minus 2, or you could write this one first. We do tend to write it in that polynomial of x equals ax times qx plus rx. Remember, this form is like this. Px over ax equals the quotient plus the remainder rx over the divisor. Remember, we did that last lesson? All right? So just familiarizing you with that. Now, here we can see that the remainder is 8. Now, instead of, if you're just asked for the remainder of a division, guess what? You don't have to do the division. You can just use what's called the remainder theorem. So, the remainder theorem is as follows, and we did look at this at the beginning of the video, but very briefly. If a polynomial is divided by x minus a, then then the remainder is p of a. In other words, you just substitute whatever a is into your polynomial, and that will give you the remainder. Okay? So, we'll just come down here. So, it's being divided by x minus 2, so therefore I should do p of what? P of 2. We're dividing by x minus a. In this case, a is 2. So we just do p of 2. And when I do p of 2 into this polynomial, I should get the remainder, which is 8. So p of 2 is 2 cubed plus 3 times 2 minus 6, which is 8 plus 6 minus 6. We can see that that equals 8. So notice I've got my remainder by dividing, But if I just, because I'm dividing x minus 2, it has to be in that format x minus. So if I was dividing x plus 2, I would substitute in negative 2 here. So if you're dividing by, x minus a, you substitute in the a, and that gives you the remainder. See, the remainder is 8. The remainder theorem. Question 1 says to carry out these divisions. We already did that for homework last night, where we divided one polynomial by another. We're just going to go to question 2. Find the remainder when the first polynomial is divided by the second polynomial. And I'm just going to do questions C and D. Okay, so let's have a look at those. So, just getting your exercise book. So, find the remainder when, I'm going to do this one, this is the worksheet, when x to the power of 5 minus x squared minus x minus 1 is divided by x plus 1. Okay, now we don't have to do the whole division. Yes, we could if we wanted to waste a bit of time, but if we just want the remainder, that's all they're asking for. Remember, we're dividing by x plus 1, which is x take away negative 1. So what do we substitute into the polynomial? Polynomial of negative 1. That gives me the remainder. So the remainder theorem is, if you're dividing by x minus a, you substitute the a into the polynomial, that gives you the remainder. So p of negative 1 is negative 1 to the power of 5 minus negative 1 squared minus negative 1 take away 1, which is negative 1, what? What do I get now? Minus, this will be 1, plus 1, minus 1. Which is negative 2. So if I did do that division, the remainder would be negative 2. That's what I would end up with. Okay? 2D, find the remainder when 4x cubed plus 4x squared minus x minus 5 is divided by 2x minus 1. Now this doesn't look like, this does not look like, you know, it's meant to be in the form x minus a. So what do you think we should do here? I'm just going to, if I just put this 2x, what I'm going to do, let's actually do this one. Let's divide it, and then we're going to see what we're going to divide this one just for practice, and then we're going to see what we think we would substitute. All right? So let's just divide. So we're just going to do a normal division just for practice. So 2x minus 1 into 4x cubed plus 4x squared minus x minus 5. Okay, let's just do that, and I'll turn the video back on when we're done. Is that what people got? Negative 4? So when we do that division, we get negative 4. So what do you think we're going to substitute? What would you like to do with this? I'm just going to write 2x minus 1 equals 0. What could you do here? Just divide by 2. So why don't we substitute a half or negative a half? Oh, sorry, I'm off screen. So I'm just dividing by 2's because it's got to be in the format x minus a. See, look, let's say I tried to solve that. Don't you get x is a half? Well, if I did try to solve that, I would get x is a half. Sorry, I'll just solve it, and I get x is a half. All right? So if you want to, isn't that normally your, like, let's say you're trying to solve this. X minus 2 equals 0. Don't you get x is 2, right? Isn't that your root? All right? So when I solve this, I get x is a half. So I substitute a half in. Okay? Or I can look at that and say that's really x minus a half is 0 by dividing by 2. All right? So we're going to substitute p of a half into the polynomial. And let's see if we get negative 4. Okay? So p of a half into the polynomial, that's 4 times a half cubed plus 4 times a half squared minus a half minus, or take away 5. Girls, I wouldn't be doing this on my calc. Please don't. It's just such a time waster. A half cubed is an eighth, so it's 4 over 8, which is a half. Got it? Plus, that's 4 times a quarter, which is 1. Minus a half minus 5. Well, a half minus a half is 0. 1 take away 5 is negative 4. Okay? So, if you have a factor, therefore we can say, are we okay with that? So, if your factor, not factor, oh yeah. If your divisor, so if your divisor is of the form, instead of x minus a, so if your divisor is of the form x minus a, don't you do p of a for your remainder, right? If your divisor is of the form, I'm just going to go ax minus b, we sort of, it's like we're making x the subject. We do p of what? What do we do? P of what? Watch. Ax minus b is 0. X is b on a. So what do I do? P of b on a. You sort of, if you've, like we had in the example above, 2x minus 1, just put it equal to 0, work out what x is, and then that's what you substitute, okay? Because it works for x minus 2 is 0, doesn't it? If you're dividing by x minus 2, don't we do p of 2, right? Don't we do p of 2 here? We do p of a half, all right? Okay, so that's if your factor isn't in that form x minus a, all right? Remainder when 3x cubed plus 2x to the power of plus 2x squared plus kx minus 4 is divided by x plus 2 is equal to 2. So in other words, when you divide that polynomial by x plus 2, you get the remainder is 2. Now, yes, I wouldn't want to do a division with a k in it. You're not doing this by dividing. I mean, I could. It'll get quite messy, but because I'm going to end up with all these pronumerals in my division, all right? But we use the factor theorem for this. So, if you divide, I already know what my answer to my I already know that the answer to my division is 2, or I already know when I substitute which value. What do I substitute? Yeah, I already know, so x plus 2 is x minus negative 2. So when I substitute in negative 2, what answer do I get? 2, because that's my remainder. So if I substitute negative 2, I know my remainder is going to be 2. So let me substitute negative 2. So p of negative 2 is, I put that into my original polynomial, it's 3 times negative 2 cubed plus 2 times negative 2 squared plus, remember I'm substituting x is negative 2, so what do I get here? Minus 2k minus 4. And that equals 2, because that's the remainder. When I substitute in negative 2, my answer will be 2. So that is, I'm not going to put another equals now here, 3 times negative 8, isn't it? Negative 24 plus what? Isn't that positive 4 times 2 plus 8? Take away 2k, take away 4 equals 2. Collecting like terms, I've got negative 2k, I've got negative 16 minus 4, I've got minus 20, I think, equals 2. Negative 2k is 22, and I've got k is negative 11. 11, it means that the original polynomial was 3x cubed plus 2x squared minus 11x minus 4. And if I then divided that by x plus 2, my remainder would be 2. Or if I then put p of negative 2 into it, I will get the answer 2. I mean, we can check. Actually, do you want me to go back and check it and show you? That if I do p of negative 2 again, now that I know that k is negative 11, let's have a look. It's 3 times negative 2 cubed plus 2, so I'm checking, plus 2 times negative 2 squared minus 11 times negative 2 minus 4. I'm just seeing what I get. I get negative 24 plus 8 plus 22 minus 4. Now that I've worked out that k is negative 11, I get negative, that's negative 2, negative 6 plus 8 is 2. So it works. K is negative 11. All right? All right, the next one. Find p if when that polynomial is divided by x minus 2, there is no remainder. So What am I substituting? P of what? P of 2. And what answer should I get? 0. This is actually what's called the factor theorem, is when there's no remainder. You know, when you divide one number by another, you'll get your quotient and either no remainders or your quotient and some remainder. All right? This, when there's no remainder, which is what we're going to be doing next, it's called the factor theorem. Same rule applies. You still substitute, but you'll get 0 as your remainder. Okay? So P of 2 is 0. What's P of 2? Let's substitute. So I've got 2 times 2 cubed minus 3 times 2 plus P equals 0. Instead of writing, I can write P of 2 equals that, which is 0. I'm just evaluating this. That's 2 to the power of 4, isn't it? Which is 16 minus 6 plus P is 0. 10 plus P is 0. Therefore, P is negative 10. Are we good? And let me just check. I'm just going to check it. 2x cubed minus 3x minus 10. If I do P of 2 there, I get 2 times 2 cubed minus 3 times 2. Take away 10. I should get 0. 16 minus 6 minus 10 is 0. That's correct. All right? Cubed minus 3x squared plus ax plus b is divided by x minus 1. The remainder is negative 4. And when it's divided by x minus 2, the remainder is 3. So if we do P of 1, we should get negative 4. And let's do that now. So P of 1. That's 2 times 1 cubed minus 3 times 1 squared plus 1a, which is just a, plus b is negative 4. So I've got 2 minus 3, that's negative 1. I'm just going to put that, I'm just going to solve straight away. Minus 4 plus 1 is minus 3. Because I've got 2 minus 3. Actually, you better write it all out. You don't want to make a mistake, otherwise it'll be a disaster. So you've got negative 1 plus a plus b is negative 4. So therefore a plus b is negative 4 plus 1 is negative 3. That's your first equation. Just going to do the other one here. P of what? What's the second one? P of 2. The answer will be 3. So let's do P of 2. 2 times 3, no, P, 2 times 2 cubed minus 3 times 2 squared plus a times 2, which is plus 2a, plus b is, the remainder is 3. So that's 16, take away 12, plus 2a plus b is 3. So therefore 2a plus b, that will be 3, that's 4 there. 3 minus, take away 4 is minus 1. That's equation 2. Don't want that looking like a minus. And now you can use elimination if you want. You can do, I do equation 2 minus 1. That way you don't get too many negatives. Equation 2 minus 1. So we've got 2a minus a is a. B minus b is 0. Negative 1, take away negative 3 is positive 2. And then we will get that, and then we can sub in 1. Sub that in 1. 2 plus b is negative 3, which gives me b is negative 3, take away 2 is negative 5. So we've found a and b, and so therefore I can write out what the polynomial is. So my polynomial is 3x cubed minus 3x squared plus 2x minus 5. And if you want, you can check P of 1, and you should get negative 4. And you can check P of 2, and you should get 3. Let's just have a quick check. 2 times 1, that's 2, minus 3 times 1, plus 2, minus 5. What do we get? Negative 8 plus 4. Negative 4, that's correct. And just checking P of 2 quickly. P of 2, that's 2 times 8, that's 16, minus 3 times 4 is 12, plus 4 minus 5, 4, 8. I'm getting 3. And that's correct. Okay? So it looks right. You're not going to have time to do that in the exam, but just showing you that it does work. Okay? All right, if a polynomial p of x is divided by x minus 1, the remainder is negative 1. So from that, we can write that the p of what is negative 1? P of what? If you're dividing by x minus 1, what do you substitute? 1. So I know that the p of 1 is negative 1. And if a polynomial, now the thing is we don't know what the polynomial is, but if you divide that same polynomial by x plus 2, the remainder is negative 10. So what do we know? That p of what? 2 or negative 2? P of negative 2 is negative 10. So we know that so far. Now, the question says, find the remainder when your polynomial is divided by x minus 1 times x plus 2. So, and it says, hint, use the division transformation and use ax plus b as the remainder. Now, if you are dividing by, so I want to explain why we do this. If you divide by x minus 1, x plus 2, just look at this. If you're dividing by x minus 1, x plus 2, what does that equal? X squared plus 2x minus x is plus x minus 2. So remember, just imagine yourself dividing by that, dividing your polynomial in x by x squared plus x minus 2, right? And you end up with your quotient up here, and you end up with your remainder. Now, don't we stop the division when the remainder has a degree less than x squared, less than 2? So your remainder could be a number, or it could be something like 2x minus 1. Do you get that your remainder could have an x in it, or it may not have an x in it? But the highest power that your remainder could be, remember when we were doing our divisions, we stopped? So that I need to write my remainder in that form of ax plus b, because I'm really dividing, but when dividing by x minus 1, x plus 2, I'm dividing by a quadratic. So I will stop my division when I've got just a degree 1 polynomial, or even less. I could have a degree 0 polynomial. It could just be a constant, but it could be a degree 1, so I have to put that my remainder is in the form of one power, of a power less than that. Okay? So, when I divide by x minus 1, x plus 2, I have to find the remainder. So, I'm going to write out the polynomial transformation. Polynomial in x, isn't it ax times q of x plus your remainder? Yes or no? We've written that out so many times. What are we, so my polynomial in x, what am I dividing by this time? This. So for my final one, I'm dividing by, my ax is 2, it's x squared plus x minus 2, or x minus 1, x plus 2. That's what I'm dividing by. So my ax is x minus 1, x plus 2. I'm going to end up, so when I divide by that, when I divide my polynomial by that, I end up with my quotient plus my remainder. Remember, polynomial in x will be that, which happens to be this, times that, plus my remainder. But I'm putting my remainder in the format of ax plus b for the reasons I just showed you. You can't just say your remainder is a constant. You're dividing by x squared. It could be something x plus some number, or it could be a constant. Now, if it's a constant, my a is going to be 0. Fine. But ax plus b covers all bases. Okay? So now that I've got that, I use the information from the question, which was that p of 1 is negative 1. So now I substitute p of 1 in this. And look, girls, it's not going to be hard, because when you substitute p of 1, what do you get? You get 0 here. It doesn't even matter what qx is. It doesn't matter. That wipes that whole thing out. I get 0 plus what? P of 1. I get 1a plus b. Now, what was that? What's the remainder when I divide by x minus 1? It's negative 1. So when you substitute p of 1, you get negative 1 into this. So I've got a plus b is negative 1. That is equation 1. Now I know that p of negative 2, as we said before, is negative 10. So I put p of negative 2 into this. Now when I put negative 2 into this, so this is really important in the question, girls. This is what we've got to be able to set up. When I put negative 2 into this, doesn't it wipe out this whole term? Because I get negative 2 plus 2 is 0. It doesn't matter what that is and what that is. It's all 0. Substituting in x is negative 2 in here, what do I get? Minus 2a plus b. And that equals negative 10. And that's my equation 2. So negative 2a plus b is negative 10. Same as that. That's equation 2. Okay, so I've got equation 1 and equation 2. Let's do equation 1 minus 2, elimination. Because what is a minus negative 2a? It's 3a. b, take away b is 0. Negative 1, take away negative 10 is negative 1 plus 10 is 9. And so a is 3. Lovely. And then we can just sub a is 3 into any equation. Let's do it into equation 1. And I get 3 plus b is negative 1. And so b is negative 1, take away 3, which is negative 4. Okay? So therefore, the remainder, didn't we say that the remainder is ax plus b, which is 3x take away 4. That's your remainder. The thing is, we don't even know what the polynomial is. We don't even know what the polynomial is, but it doesn't matter. All right? Now that's how you do that type of question.